Hey everyone, this is Andrew, and here's another information for you. Infinite spaces are areas that cycle at its boundary. So if you visualize a cycle, going from this way to that way, what do we notice? We're going at the same place over and over again. So that's the key point when we talk about infinite spaces, or just anything that has an infinity kind of stretching effect. So if we think of a globe like this, okay, let's have its axis right here, 23.5 degrees. That's not 23.5 degrees, but nevertheless, we have our amazing globe with its own latitude and longitude. So if you go this way, if you go all the way to the east, you're going to go to the west. Same with the north, going to the south. Same with other directions too. Well, technically it's north or magnetic north. Either way, if you go whatever direction this is, you'll end up in the same direction. We can simplify this a lot more when we come to, or come across, in infinite space with a two-dimensional circle. Assuming that this circle is perfect, this is you. And assuming that where you are is an infinite space, if you go north, where will you go? With the cycle to happen, you need to go to the bottom. That will be your path. We can visualize this when we go, or when we put another circle, which is the same thing, but if you visualize it in your perspective, not thinking about like the whole cycle right there. If we add another one, of course you're going to go south. And then the same thing, onwards and onwards. Same thing for this area. As well as when you go from left to right. Same thing happens. And for the diagonals. We have this whole possibility of what other room or where you'll be on that circle. So how's this? We have the same circle, perfect circle. What if you're over here? That's not at the center. But what if you want to go here, at this direction? Where will you end up? The thing is, you can't use this area. You need to use the center. Because this center is proportional to where you'll end up. So when we go here, we also need to find this distance from the center, and then find the distance across from it. It's going to be equal, unless we'll be talking about portals, but as for now, everywhere you go, you're going to go to the opposite direction. So that is good to point out. You'll end up here, but you need to retain the same direction. You're not going to go to a different direction. Let's see. And the same thing applies. You can continue doing this space and doing this, seeing where you're across. You're going to go this way. You can probably do this onwards forever. You're going to make this shape right here. You're going to go here, back there, and it's pretty much proportional. Pretty equal. What if we have a square? This is a lot more confusing. In real life, you can't really go through a portal, or go through a portal, especially through a corner. It doesn't look safe. You're gonna find two walls, and when they meet, you'll think that you'll go here. As for now, I don't know, but the same rules apply when we're going to opposite directions. These two are opposite, and as we see, knowing that these sides are the same, half of this plus this side plus another half is the same as the other route. So of course, they're across. Same with any other distance, and the same rule applies. So when you go this direction, you need to think about the wall to the center, and then the across, and then retain the same direction, then going here. Small across. We'll go here, that same direction. Then here, across. Okay, oh, roughly this. Could be drawn bigger. But the problem is, again with these corners, you can transform any shape, like this one, like an L. You can transform this into a circle. It doesn't matter the size. It just has to be a perfect circle, and then use the same concept. And then what you'll do now, let's say you go up here, then the same area is like over here. And then we do the same center concept. We try to find where this area is on this shape. That could take a lot of your time, but it would be correct in terms of infinite spaces. So we can do the same with cubes. And of course, cubes, they're pretty obvious. They're going to go right around. Not sure about these corners. Corners right here. You can transform it into a sphere, like a globe, and with the center, it still applies. For holes, alright, I'll let you think about that, because the center is not really there. But at the same time, we can't really make this a circle. Even though I said any shape, you're still going to find yourself in a hole. You can make it a donut, sure, a perfect donut hole, which could be possible. So let's say you're going here to this direction, and if we transform this, it's going to be over here into the center. You need to find the opposite of that, which could be over here. And you can go the other way. Alright, we'll talk about more of this concept using portals, but with this sort of diagram we have here, and along with rectangles, rectangles take a lot more, because for things to be directly across, it has to be perfect. It has to have that same center concept. So we can visualize our map, our portal map, kind of like this, but it might be a lot different because of the different sizes, for it to not be ideal to use. So that's infinite spaces at a glance. If you have any questions, feel free to comment below. Thank you.